So in this case section, we're going to look at how to find the slope using the equation of a line instead of using 2 points on the line. And we're going to use this form of the line called the slope-intercept form. And it's called the slope-intercept form because here m, the number by x, or the coefficient of x, is always the slope, and b is the y-intercept. And so let's find out why. So why is b the y-intercept? Well, if you recall, the y-intercept always happens when we set x equal to 0, or when we complete the ordered pair 0, comma, blank. And so let's see what happens when I do set x equal to 0 in this equation. So plug in 0 for x. Simplify, m times 0 is 0, plus b is equal to b. So you can see that when I replace 0 to find the y-intercept in my equation, it turns out that y has to be b. And that's why 0, comma b is the y-intercept. Now, why is m the slope? Now, if you look at these 2 points, 0, comma b and x, comma y, they're both on this line. Now 0, comma b, I just noticed, or I just saw here that it's, y, it's on the line. And x and comma y are also on the line because, or the point x, comma y is on the line because if you plug it in, you'll see that you get a true statement. So if these two are on the line, that means that I can find the slope of that line, m, using these 2 points. And so I'm going to subtract the y coordinates in this particular order, so this y minus this y. And then in the denominator, because I started with y, now I have to start with x in the denominator minus the other x coordinate. Now if I do a little bit of algebra and simplify, so here in the denominator, x minus 0 is x. And now if I solve for y, so let me multiply by x to get rid of the denominator. So this becomes a 1. And now I'm going to add a b, but first let me rearrange the m and the x. And this is what I have. And now I'm going to add a b to both sides. And so you can see that if I do use those 2 points that are on the line to find the slope, you can see why m would be the number by the x when I solve for y, when it looks like my slope-intercept form. And so anytime I'm trying to find the slope in the y-intercept, all I have to do is, 1, get y by itself, so that's condition number 1, and then I can just look at the coefficient of x to find the slope, and the constant will always be the y-intercept. So let's look at some examples on how to do that. So let's look at this example. We're trying to find the slope of the line 2x plus y equals 7. So first, remember step one is going to be to write your equation in the equation in slope-intercept form. So that means it has to look like y equals mx plus b. In other words, let's get y by itself. So I have 2x plus y equals 7. Let me move the 2x term to the left. So to get y by itself. So here y is equal to, and these are unlike terms, and you can write them in any order. But if you want to start with the x variable, it would be negative 2x and then plus 7, because they're unlike terms. So now that y is by itself, now I can identify the slope and the y-intercept. So again, the slope is this number here by the x, by the variable. And it doesn't matter if the variable term was second or first, it's always the number by the variable. So it's not the order of how they appear, because I can rearrange them and still the slope would still be the number by x. And the constant, the +7, is my y-intercept. So my y-intercept would be, as a point, would be 0, 7, or you can say that the y-intercept is 7. So that's how we find the slope and the y-intercept when you have the equation. Here's another example. So again, let's start by getting y by itself. So let's move this 2x minus 2x. And this time I'm purposely going to write it where the x term is second, so 10 minus 2x. So you can see and stress that it's not the order what determines the slope and the y-intercept. It's, again, the coefficient of x and the constant. But first, notice this is not y yet, so you do have to divide by -3 on both sides of the equation. And don't forget to divide all terms by -3 so that I do have y. Remember, it has to be y equals mx plus b in order to determine the slope and the y-intercept. Here, I'm just going to write it as a negative fraction because positive 10 divided by -3 is -10/3. Here, you can see this as a negative divided by a negative. So this is positive 2/3 x. You can place the x in front of the 2/3 so you can see the coefficient here of x. And so that the slope, again, it's the coefficient or the number by x, not the first number necessarily. So don't remember it that way. It's always the number by x, not always the first number necessarily. And the y-intercept is always the constant. Or you can also check, you can plug in 0. It's not that. It won't take that long to plug in 0 and see that the y-intercept should be -10/3. So it should cross the y-axis at -10/3. Let's see, let's look at another example. Now, in this example, we're going to look at how to find the slope of a line that's horizontal. Now, we know from the past that if I graph this, let's look at the graph to see what's happening with the slope. If I graph this real quick, it's a horizontal line passing through -3. Here's -3. And my line is crossing this y value on the y-axis. Let me label my axis so you can see. So this is this is the line y equals -3. And we saw that if you pick any 2 points on this line, when we use the formula, the slope is always 0. And why? Because you're not moving up or down. And so you end up with a numerator with 0, and then the denominator is not 0, but 0 divided by 0 is always 0. So for horizontal lines, we have concluded horizontal, scratch that, horizontal lines have m or slope equal to 0. So it's not that it doesn't have a slope, it does, it's the number 0. So make sure you don't write no slope, write 0 when you have a horizontal line. And again, you will always, if you don't want to graph it, it would always have a slope 0 when you're missing x. So your equation, after you simplify it, it's going to be y equals a number. So all horizontal lines have slope equal to 0. M equals 0 for the slope of all horizontal lines. And now by contrast, when you're looking at vertical lines, like this vertical line, x equals 1. So remember, if I look at the graph of this equation, here's my y, here's my x, here's x equals 1 on my x-axis, and here is my line that passes through this 1. So here we saw that there is no movement in the x, so that my distance between my x's is always going to be 0. And so that m, because the denominator is 0 in that case, we saw that m is undefined. Or sometimes you'll see it as no slope. And so don't confuse. Remember, horizontal lines have slope 0, and vertical lines have no slope or have undefined slope. So don't confuse the two. So you can't say no slope when you mean 0, and you can't say 0 when you mean no slope. Or it's probably best just to say that it's undefined. So anytime you have a vertical line, your slope is going to be undefined. So all lines, or all vertical lines, as we specified before, have undefined or no slope. So if you have an equation, and notice if you look at the equation, when you have a vertical line, the y variable is not there. So even if you had numbers around it, if after you get the variable by itself, it's just x, it's always a vertical line. And so if that's the case, then we see that this line will have an undefined slope. Or you can say that the slope is undefined for this line. So let's summarize what the slope tells us about our graphs. So here, if your line is going upwards and always from left to right, so always read it from left to right, don't go right to left, left to right, this line is rising. So if that's the case, then your slope should be positive, or m is bigger than 0, or again, m is positive. So if you have a positive slope, then your line should be rising. Now, if m is negative, less than 0, then your line should be falling. And again, from left to right, it should be falling or decreasing. If your line is horizontal, then m is always going to be 0, right? So 0 slope when you have a horizontal line. And if you have vertical lines, m is undefined, or you have no slope. So you can always check, for example, if you're trying to check a graph, if you graph your line and then you look at the slope, and the slope is positive, for example, but your graph is showing that it's falling, then that means that we might have made an error when we were graphing. All right, so let's look at now an application of slopes and parallel and perpendicular lines. So parallel lines. Let's first take a look at two parallel lines. So let me graph two parallel lines. So say this line. Remember, parallel lines do not ever cross. So here's another line. So these two lines are parallel. And what we have to notice is that if you notice, the steepness is exactly the same, right? Because if they're not same steepness, the slantness is not the same, then these things are going to start crossing either towards the top up here or towards the bottom down here, so that their slantness always has to be the same so they don't cross each other. So that we know that the slantness or the steepness is the slope of the lines. So parallel lines must always have slopes that are exactly the same so that they don't cross. So parallel lines have the same slope. So if you find the slope of the two lines and they're exactly the same, then we know that your lines are parallel. Now for vertical lines, or sorry, not vertical lines, perpendicular lines. So if you have, let me draw two perpendicular lines, y, x. So if you have a line going in this direction, a line that's perpendicular to it will intersect it, so cross it. But, and my sketch is a little off, but this intersection has to be at a 90-degree angle. So they cross at a 90-degree angle. Now you can see one is rising and one is falling. And so that the slopes, one, they have to be opposite, but there's actually two conditions to be perpendicular. So there's two things that you have to check for. So one, the slopes are opposites. M's are opposites. And then the other condition that you can't necessarily see from the graph is that also the slopes are also reciprocals of each other. So let's look at what that means. So if you have a line with slope, say 3, so the perpendicular line to it would have slope negative, so opposite, because this one is positive, but not only opposite, but the reciprocal of 3, which is 1/3. So these two pairs are perpendicular. So this line and this line are perpendicular. Another example would be if you have slope, let's use a fraction, say like -2/3. Now the slope of the other line that's perpendicular to this one would have to have positive slope, so no negative. But on top of that, the slope of this line would have to be 3/2. So two conditions, and it has to be both. It can't just be one. And so you can't have 3 and -3. Those are not perpendicular. They have to be exactly opposites and reciprocals. So two conditions. So let's look at some examples and see if we can determine if they are parallel. So we just saw it's to determine if a line is, or two lines are parallel, perpendicular, and of course if they're not either of the two, then it's neither parallel or perpendicular, we do that by looking at the slopes. It's all determined by the slopes. So if that's the case, then the step one would be to find the slopes. So step one, let's find the slopes. Oops, sorry. Now here I have my equation, and we just saw we can use the slope-intercept form to find the slope of each of these lines. Again, here is y is already by itself, so I don't have to do that step. And if you look at the coefficient of x, that is 2/9. And if I look at the second line, the coefficient of x is -2/9. And so if we first check for parallel, notice they're not the same, so they're not parallel. Now for perpendicular, they are opposites, but 2/9 is not the reciprocal of 2/9. This should be 9/2 if it was a reciprocal. So because it's not the reciprocal, then these lines are not perpendicular, and because they're not the same, these lines are not parallel. So that means that these two lines are neither parallel or perpendicular. Now on this side, again, I need to find the slope, but unfortunately, my equations are not in slope-intercept form, so let me start with that first. So let me separate these. So take away, well actually, let's divide by 5, because that's all I need to do to get y by itself. Divide by 5. 10 divided by 5 is 2. I'll leave that as a fraction. This was 5. 3 divided by 5. Pen doesn't want to cooperate. Equals y. All right, so I can see if I look at the coefficient of x, or the number by x, that's 3/5, so that's the slope of that line. And now let me find the slope of the other line. And here I do need to move the 5x to the left to get y by itself. So take away 5x, take away 5x, and you'll have 3y is equal to 1 minus 5x. Last step, get that y by itself. So divide everything by 3. And we get that y is equal to 1/3 minus 5/3 x. And so the slope would be negative 5/3. That's the number by x. And so if I compare my slopes, they are opposites. So they're not the same. They're not going to be parallel. And notice that they are reciprocals. 3/5 is the reciprocal of 5/3, or 5/3 is the reciprocal of 3/5. So because they're both opposites and reciprocals, then that's why these lines are perpendicular. Perpendicular lines. So if they were the same, we would have said parallel.